first thing we're going to do is go through and graph all of the parent functions. And the first one is pretty straightforward. It's just this simple linear function, and it's a line. Linear means line. So the parent function is f of x equals x. It's just that simple. F of x is going to be our new y. So this would be the same thing as saying y equals x. So if I graph this, it's just a line with a slope of 1 through the origin. So there is going to be your linear parent function. Next up, we have the absolute value. So the absolute value is f of x equals the absolute value of x. And if you remember, the absolute value just takes a number and gives you the distance from 0. So a positive stays positive, but a negative stays or switches to positive. So if I plug in 0, the absolute value of 0 is 0. If I plug in 1, the absolute value of 1 is 1. The absolute value of 2 is 2. 3 is 3, and so on. But then in the negative direction, the absolute value of negative 1 would be positive 1. Negative 2 is going to be positive 2. And it's going to continue that pattern forever. So the absolute value is always shaped like a V. The vertex of the absolute value is that point where the two lines meet in the middle of the V. So that's what we call the vertex. Next up, we have the quadratic. So you've seen these before, but f of x equals x squared is the parent function. So if I plug in 0, 0 squared is 0, 1 squared is 1, 2 squared is going to be 4, and 3 squared is going to be 9. If I continue, 4 squared would be 16. Remember, when you square something, you multiply by itself. But what if I go in the negative direction? So the negative 1 squared, that means negative 1 times negative 1. So if I multiply negative by a negative, it gives me a positive. So negative 2 squared is negative times negative, so it's going to be positive 4. Negative 3 squared is going to be a positive 9. And there's going to be your quadratic function. Now, a quadratic is shaped more like a U than a V, and we call this a parabola. So take note of that. This is what we call a parabola. The vertex, again, is that center middle point, so it's at 0, 0. Okay, there's our quadratic function. Then we have cubic. So f of x equals x cubed is the cubic function. So if I think about 0, 0 cubed is 0. 0 times 0 times 0. 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is going to be 8. 2, 4, 6, 8. 3 cubed would be all the way up at 27, so we're running out of room. But what about the negatives? So if I take negative 1 cubed, negative 1 times negative 1 times negative 1, it's going to come out to be negative 1, right? The first two negatives give me a positive 1. Positive 1 times negative 1 is negative 1. Then negative 2 times negative 2 times negative 2 is going to be a negative 8. So there's our dots for a cubic function. So to draw your curve, just connect your dots in the middle. You're going to have a little wiggle through the middle. And it's going to look something like that. So you have a little squiggle through the middle. So there's our cubic function. If you notice, let's add a note here that we'll call the turning point. And the turning point is like the center of the graph, kind of like the vertex. And this one's at 0, 0. So that turning point is the point there at the center. And if I rotate this thing around that turning point, it's going to line up with itself. So this has rotational symmetry because I could rotate it and it's going to look exactly the same. Right? I could spin this around and it looks exactly the same. So that's rotational symmetry, and cubic functions will always have that. So next we have the square root function. That is f of x equals the square root of x. So if I think about graphing this, if I plug in 0, the square root of 0 is 0. The square root of, write those out because this one, think a little bit. The square root of 1 is 1. And the square root of 2 is not going to give me a whole number. I could put it in my calculator and get a decimal. It's going to come out to 1.4142133562 and keep going forever. So let's keep thinking here. What about the square root of 3? Again, it's not going to give me a whole number. But what about the square root of 4? That's going to give me 2, right? Because the square root function asks for a number times itself to give you that number. So 2 times 2 gets you to 4. So the square root of 4 is 2. So if I go over to 4, 1, 2, 3, 4, go up to 2, it's going to give me another dot. And to get the next one, square root of 5 doesn't work, square root of 6 doesn't work, square root of 7, square root of 8 doesn't work until I get to the square root of 9. Square root of 9 is going to give me 3. So if I go over to 9, down, and finally up to 3. And then if we think about negative numbers, you square root negative 1. So that's asking for the number times itself to be negative 1. And you might think, well, negative 1 times negative 1. But that doesn't work because that'll give you positive 1. But we need it to get back to negative 1, which doesn't work in the real numbers, which is why we will have another set of numbers called imaginary numbers that we will use to square root negatives. But for now, we're going to just be working with real numbers. So there is our square root function. The end point of that is kind of like the vertex at 0, 0. And you might notice that this looks a lot like the quadratic function. It's just on its side. 2, 3, 4. So if you look at this on that dotted line, it's just a reflection across there. But that's not super important right now. Next up we have the cube root. So this one's f of x equals the cube root of x. So to write that, you put a little 3 there on the square root sign. And the cube root is going to be the inverse of the cube function or cubic function, asking for the number times itself 3 times to get you to x. So the cube root of 1 is 1 because 1 times 1 times 1 is 1. The cube root of 2 doesn't exist. But what's the next number that does exist? So the cube root of 8 is going to be 2 because 2 times 2 times 2 gets you back to 8. So if I got the 1, 1 there, 2 is going to go all the way up to 8. And then 3 is going to go all the way up to, whoops, I did that backwards. I need to go over to 8 in order to go up to 2. Okay, and then to get up to 3, I have to go all the way over to 27. So that's as far as we're going to go there. But what about the negatives? Now, with cube root functions, the negatives do work because negative 1 times negative 1 times negative 1 is negative 1. And then kind of like 8 and 2, the only way to get down to negative 2 is to go all the way to negative 8. Because negative 2 times negative 2 times negative 2 is negative 8. So there's my cube root function. And you should notice that this looks a lot like the cubic function, just rotated or actually reflected. And then the turning point is going to be 0, 0. That's that rotation point in the middle. I could rotate this and it'll end up the same, just like the cubic function. So next up we have the exponential function. And this is a new one to you. So if we have f of x equals 2 to the x. So now your variable is in the exponent. And so if we think about this, if 2 to the first, if I plug in 1 for x, 2 to the first is just 2. So if I go over 1, I go up 2. 2 to the second means 2 times itself, so 2 times 2 is 4. So if I go over 2, I go up 4. And 2 to the third means 2 times 2 times 2, so that's going to be 8. So if I go over 2, I go up 8. And what about 2 to the fourth? So 2 times 2 is 4, times 2 is 8, times 2 is 16. So that obviously doesn't fit on our graph here, but notice the pattern. So each step going up is getting multiplied by 2. Right? You can also think about the pattern in reverse. So going backwards is getting divided by 2, divided by 2, divided by 2. So what about 2 to the 0? So do the backwards pattern again, divide by 2. 2 divided by 2 is going to be 1. So at 0, I'm up at 1. Okay, let's go again. What about 2 to the negative 1? So I just divide that by 2, I'm going to have 1 half. So at negative 1, it's up at a half. And let's keep going with our pattern. So 2 to the negative 2, half of a half is 1/4. So go to the left 2 and up 1/4. And let's do one more, just to notice the pattern a little better. So 2 to the negative 3, half of a fourth, is going to be 1/8. So if you look at the denominators, they're just getting multiplied by 2. Okay, so going over 3, it's going to go up 1/8, which is barely even above the x-axis. So an exponential graph is going to barely be above the x-axis and then curve going up, and it's going to increase it's going to increase faster and faster as you go to the right. As you go to the left, it's going to approach the x-axis, which means it doesn't actually get there, but it's going to get really close to it. And eventually it's going to look like it, but never technically be at 0. Because you could keep dividing by 2 and dividing by 2, but you never actually get down to 0. So there's our exponential graph. Okay, the last one we're going to look at is the reciprocal function. And this is f of x equals 1 over x. And all this does is it takes the reciprocal of every x value that you put into it. So if I put in 1, I'm going to get out 1. If I put in 2, I'm going to get out 1/2. The reciprocal of 2 is 1/2. If I put in 3, I'm going to get out 1/3. 4 is going to be 1/4, and 5 is going to be 1/5, and so on and so on. The interesting thing about this is what happens between 0 and 1. Because if I put in 1/2, it's going to take the reciprocal of 1/2 and it's going to give me 2. So 1/2, I'm up at 2. If I put in 1/3, it's going to be up at 3. 1/4, it's going to be up at 4. 1/5, up at 5, and on and on. And again, it's going to approach the y-axis, but it's never actually going to reach the y-axis instead of the x. It's going to approach the x-axis, but never actually reach it. And then I actually cannot put in 0. 1 divided by 0 is undefined. So it's not part of the function. I can't put it in. I can't plug in 0. But negative 1 is going to be negative 1. Negative 2 is going to be negative 1/2. Negative 3 is negative 1/3. Negative 4 is negative 1/4. Negative 5, negative 1/5. And negative 1/2 is going to be negative 2. Negative 1/3 could be negative 3. Negative 1/4 is negative 4. And that's what the reciprocal function does, is it just takes the reciprocal of each of all of the input values. Okay, that's all the graphs that we're going to graph. The rest of the information I'll give you tomorrow.